So welcome to the computer graphics practice video. The task is UV mapping, and UV mapping is mapping an image onto some mesh or a 3D object. So the idea is that if we have a cube or whatever object you have in 3D, just saying that this object is red, or maybe specifying certain colors for certain vertices and then having this interpolation between the colors often isn't enough to show fine detail of the object. So for this texture mapping or UV mapping helps us. We can send images to the GPU, and if we have defined a mapping from the coordinates of the surface of our mesh to the image space, then we can sample the image at specific coordinates, find different color values, and use them as colors for the fragments on our mesh. So for example here, we have this quad, we have this image. The image is in UV space, so the bottom left is 0, 0, top right is 1, 1, and this is the UV space. No matter what size your image is, it will always be in that space. And then we have some mesh that has all sorts of different coordinates here, and if we say that this vertex top left here has the UV coordinate of 0, 1 of this image, and the top right one has 1, 1 of this image, and so on, map all of those corner coordinates to those vertices, then we can interpolate between the UV space coordinates along this mesh, and at each fragment we can sample a pixel value or a color value from the image. So this is texturing. The task here is quite simple. We have this one quad, and you should implement the UV mapping, and in a way where this image is repeated 4 times along this quad. Now if you open this up in your browser, then you find this red quad. That's because there's no UV mapping. This flying white dot here is the light source. If we look at the code, then there is this light position again, like we had in the previous task. The light is flying around in our scene, and there is this curve. This is all quite similar than we had before, and I just added this small sphere where the light is. What else? So we have this key listener. So there are actually different images we'll be loading, and on key press you could switch those images. Now the images we'll be loading are in this folder in this web server. So the problem here is that Chrome doesn't allow you to fetch images from your local file system without some different flags and security things, configurations. So because of that, my uploaded images will be using up here in this folder. The image file names are here, and also this cross-origin thing is important because we'll be fetching them from another domain, I mean your local domain, and so this in order for this loader to work, it needs to use this cross-origin anonymous flag as well. Right, so in 3GS there are different loaders for different files. We'll be using texture loader. Loaders work like this, that you say load your file name and a callback function. So when the function is loaded, then this callback function is run with this texture that it just loaded. Another thing I have implemented here is this textures to load. So this is currently 4, so we're loading 4 textures. And when these textures have all been loaded, then this function is called, and then we go to the draw loop. This is this way because if the textures aren't loaded yet, then we don't want to go into drawing a quad without a texture which isn't loaded. So we'll wait until all of the textures are loaded and then go to drawing loop here. Okay, change texture just changes the texture. We'll have an array of textures. The task here is to add this texture to the array, and when the texture index changes, we switch to another texture from the array. Everything here is pretty much the same we had in the previous task. There is some attributes we need to assign here, and yeah, down here you should copy your Fongs lighting model or Blinn Fongs lighting model, whichever you want, and also UV coordinate interpolation. So these are for the lighting model is for you to see how the lighting works on the textured surface. Right, but we'll get to those. So first thing we should do here, when this texture is loaded, we need to add it to this textures array. So we have these textures, push this texture, yay. But another thing is that textures have different magnification and magnification filters. So as we saw on the lecture, the magnification and magnification filters, if you scale your image up a whole lot, then the question is how do you find the missing values, because your image is a grid of values, discrete values, and what are the values between the pixels. Because if you have 2 pixels and you try to fit them on a 20 by 20 pixel area, then how do you fill rest of the pixels there? Same thing with minification. So this is probably a place where we would want to go to the 3GS documentation. So let's go to the 3GS site, take documentation, and see what do they say about textures. So texture object. And what we can see, there is the texture loader, the same thing we used here. There is this load, the file, and there is this wrapping node. So this is the kind of the repeat part. So as we also discussed in the lecture, what happens if you go outside of the UV space, so over 1 less than 0? Will it clamp? Will it repeat? What will it do? And you can read about different parameters you can use here. So you will use some tiling things, but also this magnification and minification filters are important. So what are the default? Default is linear filter for magnification and linear mip-map linear filter for minification. So what does the task say? Yeah, you may want to change them. So if you want to find out what does the nearest neighbor filter, for example, do, so there is this texture constants page. So you would use the nearest filter and see how your images maybe get pixelated or maybe not. So this is something we might want to try out. So I'm going to the mag filter and min filter, take those here and say texture mag filter, and let's put nearest filter for that, and min filter as well. But the effect of this we'll see actually later on, so you can do it later as well. But you do want to make the texture repeating, so how do we do that? Let's see, repeat wrapping, and the default is clamp to edge wrapping. So this is the wrap S and wrap T that are in this example here. So we're going to use those and specify that those textures, this wrapping should be repeating the texture. And also we want to say that it needs update, so because we have changed those values there. Okay. So now we should have the textures in this array. When we are adding this quad, there is this great texture quad. So how does the texture end up on the quad? So there is this shader material, and we can see that this texture is one of the uniforms. So that's all good, but even if this is a uniform, like it is accessible from all of the fragments and vertices, we still need to create a mapping for it. So we want to know which vertices correspond to which points on the image. And this is where this create textured quad function comes into play. So what we want to do is we want to create a new float to array. So let's call it UV chords maybe, equal to new float32 array. And we have this plain buffer geometry. So we have 4 vertices, so we need to put 4 elements in this float32 array, but each element has 2 coordinates. So remember, this is the UV space is a 2-dimensional space, so what we'll be using are 2-dimensional vectors. But in float32 array, of course, they will all be in one row. And we currently don't know like which will the first one be the 0, 0 vertex, second one 0, 0. So what we'll do is just put some values here, and we'll see in the end how do those values actually map to our vertices. So now that we have this float32 array, we need to create the buffer attribute and use the add attribute to assign it to the geometry. So let's go see this buffer attribute. Do we have an example? No, we don't have an example here, but we see that it's the array and item size. So basically, maybe we can have this geometry, buffer geometry. Yes, so add attribute, this is the example we wanted. So we have the geometry, this is that. We add an attribute, we call it UV chord because the UV is already reserved by 3GS. It does actually send the UV coordinates itself, so but I will be using a role in this task. So the UV chords and item size is 2 because they are 2-dimensional vectors. Okay, and in order to check that we really get those values now in the GPU, let's go to the shader code, and in the vertex shader we need to have an attribute. So even the task says this, get the attribute UV chord, and this is vec2 UV chord, and these are the each values here that we have specified for each of the vertices. We also need a varying vec2, and let's call this interpolated UV. So this is the value that we interpolate over the whole face. So interpolated UV will be equal to UV chord. And we also want to receive the varying vec2 interpolated UV now in the fragment shader. And when we have done this, we need to see what are the values in this variable. So the easiest way to debug this is to just put them as red and green colors in this fragment color. And let's see if we have made any mistakes here. And this is the result that we got. So currently it seems that the first vertex 0, 0 is up here. Now this isn't what we want. We want 0, 0 to be down here because the image is mapped that way. Also we see that 1, 1 currently happens to be up here. So what I'm going to do is, let's take the 0, 0 and let's replace this with the green color here. And let's see again. Okay, now we have this black color down here, but the yellow is still wrong. So I'm going to switch this yellow with the red one and put the red one down here and see what happens then. Maybe we need to switch one more time. So now yellow is up here. This coordinate is 1, 0, which is good because this is the first axis and this is green, so this is the second axis, and it seems to be totally correct. You will see why this is correct in a moment, but just black is 0, yellow is 1, 1, red is 1, 0, and green is 0, 1. So this is a good way to debug your attributes. Just assign them as colors and think about are the colors representing the correct numbers. Now we sent some texture as a uniform somewhere up there, right? Or here. Now we need to fetch this, so receive the uniform texture. And the question in these comments is that what type this texture is. Now this is the part where you can Google again, so WebGL, let's say texture sampling maybe of textures, using textures in WebGL. So this seems the perfect thing that we want. Okay, it's going to talk about something loading texture, so this is on the CPU side. This we don't care about, we have already done all that. Updating the shaders. Now these shaders is what we want to see. So there is this texture chord interpolation that we have already done, and now here this is how this texture coordinate is used, and this is what we're interested in. So the texture is called a sampler 2D. So our uniform here is sampler 2D. How did we name it? We named it texture, so let's call it texture here as well. Otherwise it doesn't know what do you want. Now we have this sampler 2D typed object called texture, and to sample it, it says texture 2D. This is now a function, the sampler and the coordinates. So what we can do is call this function on the texture and with the interpolated UV coordinates. Now this gives us some value, and it seems here that because this is assigned to frag color, it gives us a 4-dimensional value. And because we don't have like some blending or alpha or transparency thing here yet, we're going to use just the first 3, so we can just take RGB values from this result, and this is what we want as the color. Right. So we sample the texture with those coordinates using this function, take the first 3 coordinates of the result, this will be our color, and assign this as the color of the fragment. And let's go see what happened. And if I refresh this, we get this image of this guy here. If I press the arrow keys, it seems that the images do change. Now what you can see is that this guy is quite pixelated. If I zoom in, you can see the different pixels here. Of course there is like a limit to this resolution as well, but now I'm wondering if I have this linear interpolation filter instead of the nearest neighbor filter, will I get a better result? So if I refresh this, it seems, well, it's still like somewhat pixelated, but the result is much smoother, so it seems a bit better. And now you can start doing all sorts of weird tricks with this sampling the texture. As you saw, the task asked you to put the image here 4 times. So there are different ways how you could achieve this. You could change the coordinates here, or you could somehow change this value. So you can kind of figure out like which value you want to change and see what happens. Now what I currently want to check out is what happens if I move the camera viewer position a bit further away. So let's see what this does. Okay, this is it. That. So this moves the camera further away, so the image gets kind of smaller. And I just wanted to see that if I now use the nearest filter, yeah, so this image got really pixelated if it's smaller. I'm just zooming the browser window, so you can see that this is really not good. But if I don't use the nearest neighbor filter but the linear bitmapping filter, then this is much better. I would also try a linear filter without bitmapping. That would also be interesting. Okay, so feel free to experiment with those filters, see different results, how your texture looks like. There are different textures, so they each have their own different interesting patterns on them, and see how you can make the image repeat 4 times on the quad, and have fun.